Hello everyone, welcome back to my YouTube channel, and today I will be solving one more lead code problem, that is leaf similar trees. So let's read out the statement. Consider all leaves of a binary tree from left to right order. The values of those leaves form a leaf value sequence. So if we are going from left to right, and we are checking the leaf nodes. So what are the leaf nodes? The leaf nodes are those nodes which do not have any child nodes. So the left node for this 6 is also null, and right node is also null. Okay, so this is a leaf node. Similarly, it is for 7, 4, 9, and 8. Now it is saying if we are going from left to right, if we are going from left to right, then it forms a sequence that is known as leaf value sequence. So what is the leaf value sequence for this particular shown binary tree? That will be 6, 7, 4, 9, 8. Fine. So let's read further. For example, in the given tree above, the leaf value sequence is this. Fine. Then two binary trees are considered leaf similar if their leaf value sequence is same. So now question is saying that we have given two binary trees, and these two binary trees will be considered leaf similar. So this is a term leaf similar if their leaf value sequence is the same. So if we have given two binary trees and their leaf value sequence is, if for one tree is it is 6 4 6 7 4 9 8, then for other also if it is 6 7 4 9 8, then we can say uh, uh, we will not worry about the other structure of the binary tree. We are just concerned about the leaf value sequence. So then we can say if their leaf value sequence is same, then they are leaf similar. Okay, so on the basis of that, we have to return true or false. And we initially we have given the root 1 and root 2, their nodes, head nodes. Okay, fine. So let's see one more example for more clarity. So here we can see both the binary trees are looking very different, but their leaf value sequence is same. 6 7 4 9 8, 6 7 4 9 8. But their structure is pretty different. This has two child nodes. Fine. This has got 5 has got 2, and then one has got 2, 4, and 2. But here 2 has got 9 8, but here one has got 9 and 8. So their rest of the structure can be very different, but their leaf value sequence, that is same, that is same. Okay, fine. So what I will do here is I will be taking two lists, and I will be storing the leaf value sequence one by one of both the binary trees. Now, how will I store the leaf value sequence? That I will do by applying DFS, that is depth first search. So I will be going to the entire depth of the tree in the leftmost node, and then I will be coming back to the right. Then likewise, I will store all the nodes. So that we will see in the code. So let's move towards the code. I will take two lists. So first I will take list L1, that will be of integer. Both lists will be of integers. So list L1 will be new array list. Fine. And this array list, I will copy it once more because we need two array lists. Okay, fine. I will name it as L2. Fine. Now let's then I have to do something over this root 1 and root 2. These both the trees, these both the binary trees, in order to populate these lists. So for that, I have to implement DFS, and DFS is a recursive algorithm to iterate over binary tree. So I will implement that. So let's name a method. Let's make a method, suppose collect leaves. Okay, collect leaves, and this method will take my list L1. Okay, or it will take this root one tree, the head node of the tree, and it will take the list. Now, now it is the responsibility of this collect leaves function to populate this list L1 with all the leaf nodes of this root one root one tree. Okay, from left to right direction. So this function is done. I have to provide the implementation of this function. So I will write it later. Okay, fine. And then in the end, I will return L1 dot equals L2. So this is the collections method. So it will tell whether these both sequences are same or not. Fine. So now my this collect leaves function has need to be implemented. So for that, I will write, I can write private here. This method can be private. So private, and it should not return anything. It will return void. Then it should be static also, because I can call without making the object. And this will be the name. And it will take first what? It will take a tree node, and let's name it as root. And it will take a list of integers. Okay, this I should be capital. Okay, list of integers, and this will be, let's say, L. Okay, fine. Now let's write the implementation. So first of all, we will check that whether if our this root, this thing will is null, then we will return straightforward, because our tree is empty in that case. So if our root is null, so this is very basic thing we check before iterating over any such data structure. So if root is null, then we will simply return. Fine. Now our condition. Now what should be our condition? If my if suppose I have come at this node, the 6, that is a leaf node. So in this case, I will check with my left node should also be null, and my right node should also be null. So in that case, I will add this particular number to our list. So I will be writing that condition only if my root, okay, root dot left, if my root dot left equals null, and my root dot right equals, let's make it a little bit prettier, uh, equals null. In that case what I will be doing, I will be adding L dot add what, root dot, so the value is stored in this this is the implementation of tree node. So we can get the value by putting dot well. So root dot well. Fine. I will be adding this, and after adding this, I will be returning. I will return. Okay, fine. And if it is not the case, then I need to call. Suppose I am at 3, and at 3 it is not null. Its left is also something, its right is also something. But first I need to go into the left direction. So I will be calling this collect leaves function again, but now for this left node. So this will be a recursive call for this next node. So I will be doing that only. I will write here collect leaves, and I will call by writing root dot left comma L. Okay, and again I will be calling it for root dot right comma L. So why why again I need to call it for the right? Because once it will be done, suppose the execution has come until 6, then from this point it will return, and it will return where? It will return at 5. It will start backtrack, and at 5 it will check then, because this line has done now, left till left it is done. Now it will go for the right, and as it will go for the right, from here again it will start uh, execution for the left direction. So, and after finishing this 7, it will again return, and it will then go for the right. So this way this recursive function will handle this left and right direction for every node. It will keep on checking, and it will keep on uh, proceeding in that manner. So this will be the entire code for this problem, and now I should show you by running this. I hope I have not made any mistake this time, and it is giving me a wrong answer. It is giving me false. So let's check what have I done here wrong. So I am adding this root dot well, okay, when both are null, and in this case I'm returning fine. Okay, fine. This is the mistake. Every time I am making mistake nowadays, I don't know why. In both the functions I'm passing root 1. So I need to pass root to here, and I need to pass L to here. Now this is fine. Now I will run. Now it should get accepted, because in hurry you make mistakes. So this has got accepted. Now let's submit this, and this is done. Okay, fine. So this has got accepted. So that's it for this problem, and I hope you have understood this. And if you have any questions, you can ask in the comment sections. And keep learning, keep watching. And if you like this video, then please do share with your friends and subscribe to the channel, because so that you can get updates of new upcoming videos, and so that we can learn more uh, stuff. So that's it for this video, and I will see you in the next one. Till then, bye bye. Take care.